because he's worked really hard on learning all the tricks with binomials, and who doesn't like someone who's always as happy as Cam is? And we'll do a second shout out to Anna for pulling it together and working really hard on the math. So today's goal is to just recap all the rules that you went over last week. So last week we asked you to try and discover the rules on your own, because if you were able to discover them, then they would make more sense to you. And a lot of these rules are just kind of common sense rules. So now we want to recap them. There were some rules that were harder than others for people. The first rule that you tried to discover was what happens when you multiply and you have powers and your base number is the same. So on the video that we had you watch, you actually expanded out each problem, each term. So w to the fourth would be 4 w's, multiplied by 3 more w's, multiplied by 1 w. And then your answer written as exponential form would be w to the 8th power, because you would have 8 w's. But instead of having to write it out all the time, the rule is you can just add your powers. The tricky thing would be to remember that this w has a power of 1, and not to forget adding that. So we get w to the 8th power. Here, I'm going to have 2 w's multiplied by 3 more w's, and I can expand it, or I can learn the rule that says you can add the powers. So we get 2 to the 5th power. If you have a problem where it's numbers and 2 to the 5th power isn't that hard to do, you usually expected to do that math out and get the answer. So in standard form, that would be 32. The next example, here's a multiplication problem, but now we have coefficients. So we're going to multiply those like we would normally do. 7 times 6 is 42. And now we're going to add 5 x's plus this one other x and get x to the 6th power. And then our last example, we're going to multiply our coefficients. Negative 3 times 5 is negative 15. And then we're going to go variable by variable and add them together. So we have 2 y's here and 1 y there, so that gives us y cubed. We have 7 z's and 6 z's, so that gives us z to the 13th power. So that's the rule for multiplying. You add the powers. But if you don't remember the rule, you can always expand and figure it out. So our next rule is what happens if you have powers being raised to another power. So here we have u squared being raised to the 8th power. So if you expand u squared 8 times, you would have altogether, you would have 16 u's. So u to the 16 is your answer in exponential form. The rule says you can just multiply 8 times 2, because that's you're going to have 8 sets of 2, so you get u to the 16th power. Here, if I use the rule, I'm going to multiply 2 and 3, and I'm going to get 2 to the 6th power. Again, because this isn't a very large number, I know that 2 to the 5th power is 32. 2 to the 6th power is just double that, which is 64. So this is exponential form, and this is standard form. Now the next rule, we didn't have you discover, it was kind of built right into the other one. But if you have more than one thing as your base being raised to a power, for this example, it would be xy 9 times. So you could write that out 9 times, or you can distribute the 9 to both the x and to the y. So if you have a power outside the parentheses, it would get distributed to everything that's inside the parentheses. And if I keep writing this out, you would quickly see that I would have 9 x's and 9 y's. So this would be my answer. For the next example, I'm going to distribute the second power to each thing in parentheses. So I would have 3 to the 2nd and z to the 2nd. 3 to the second is 9. Z to the second is just Z to the second. But if you didn't remember the rule, you could always just expand this and write 3Z times 3Z. Multiply your 3's, Z times Z would be Z squared. So if you don't remember these rules, it's okay because you can always expand and get your answers. The next one, if I distribute that 3 to everything inside, it goes to the 4. It goes to the V, which already has a 3. So powers to powers, I'm going to multiply. I'm going to send it to the W. And I'm also going to send it to the X. So this is my answer, but we can't leave 4 to the third power. We need to do that out. 4 times 4 is 16 times 4 would be 64. So this would be your answer. And then the last one, I'm going to send that squared to everything that's inside. So it's going to go to the 7. It's going to go to the Y. And it's going to go to the X squared. Powers to powers, I'm multiplying. Again, you could write it out and expand it if it makes it easier for you to do it that way. 7 squared would be 49. And then we'd have y squared x to the 4th. Now our division rules, if when you're multiplying you're adding, it only makes sense that when you divide you subtract. But I don't like to think of it that way. I like to think of it as canceling. For this problem, if I expanded my top, I would have 6 y's on top. And I have 1 y on bottom. And when you reduce any fraction, if you have the same thing on bottom as on top, you can cross it off. So I would end up with 5 y's. The rule says to take your exponent, your powers, and subtract them. 6 minus this one would give you y5, y to the 5th power. If I use the rule here, 13 minus 11 would give me 6 to the 2nd power, which would be 36. So my answer in standard form would be 36. For this next one, this division problem, I'm going to look at my variables and I'm going to decide where do I have more, on top or on bottom. So for my y's, I'm thinking of them separately. I have 7 y's on top and 5 y's on bottom. So I have 2 extra on top, so the 2 extra are going to stay on top. For my z's, I have the same amount, z9, z9, so they would all wipe each other out. They would cancel each other out and become 1. And now I'm going to reduce my fraction. 10/15 becomes 2/3. So this would be the solution to this division problem. Now for the bottom, if you are raising a power of a quotient, if you have a division problem inside being raised to a power, both parts of the division problem get that power sent to it. So the rule says if you have this, you send the 2 to the y and to the w, or to the v. Looks like a v. You send it to both. If you didn't remember that rule, you could take your fraction and write it out twice, and you'd realize, oh, I have v squared or y squared on top, and I have w squared on bottom. For my next one, I'm going to send the square to both the 3 and to the 5, if I use the rule. So I would have 9 over 25. If you don't remember the rule, you can just write out 3/5 times 3/5, and you would get 9/25 also. The next rule that we're going to go over is the 0 rule, which is probably one of the easiest rules. Anything to the 0 power that's not 0 is just 1. So x to the 0 power is just 1, assuming that x is not 0. Here, this whole parentheses is the base because the 0 is outside. So they could write as much as they want inside. It's that whole thing to the 0 power, so that whole thing equals 1. And then the last one, the 0 is only attached to the x because there's no parentheses there. So we have 8 times x to the 0 plus 5. X to the 0 becomes 1. And now if we do PEMDAS, 8 times 1 is 8, plus 5 gives us 13. And now our last rule was the trickiest for all of you this past week. When you have negative powers, if you think of every number as a fraction, so don't think of this as x, think of that as x over 1. So this would be x to the negative 3 over 1. If you have a negative power, negative powers become positive by doing the reciprocal. So this x is not happy being in the numerator, it wants to be in the denominator. So I'm going to send the x to the third power to the denominator. If there's nothing left in my numerator, I'm going to make it a 1. We're just flipping where the negative is to make it positive. For this next one, I'm going to think of this as 3 to the negative 2 over 1. But 3 to the negative 2 isn't happy. It wants to be down in the denominator. So I'm going to send it to the denominator as 3 squared, which is 9. If there's nothing in my numerator, I'm going to put a 1. And then this next one, it's negative 3 that's in parentheses. So it's negative 3 to the negative 4th power. It's not happy, so I'm going to bring it down to my denominator and make it negative 3 to the 4th power. So the base still stays negative. It's only the power that's becoming positive by switching its location. And if you do negative 3 times negative 3 times negative 3 times negative 3, you would get 81. And my last one, negative powers are reciprocals. So I'm going to do the reciprocal of what's inside because it's already a fraction. That's the easiest way to make that a positive power. So I'm going to flip what's inside, and it looks like it's 1 to the 4th, 1/4. Is that 1/4? So I'm going to flip it and make it 4 to the 2nd. So if you have a fraction being raised to a negative power, you can flip it and make it positive. Oh, it's 3/4. So 4. It's 3/4. All right. So I'm going to flip it and make it 4 over 3 to the 2nd power. So now I'm going to do 4/3 times 4/3 and get 16/9. So anytime you have a fraction that's being raised to a negative, do the reciprocal and it will automatically make it positive.